can't do a graph. I need to perfect this. I should have put positive and negative and above and below, and that would have been way nicer. But anyway, we were at least introducing the idea of, if this is a functions graph, where are all these different things happening? Where is the slope decreasing? Oh, when the function's concave down, where is the slope increasing? Oh, when the function's concave up. Points of inflection separate the slope increasing, decreasing. Critical numbers separate the original function increasing, decreasing. All of that was kind of building up to this. Where I'm curious whether or not you can summarize something like, if f prime of x is greater than 0, what can I say in context of a problem as far as how something is changing? What is changing and how is it changing? The function f of x, the quantity is increasing, right? Now, if you're talking about a ball like in flight, well, maybe it's rising instead of increasing. You wouldn't necessarily say position is increasing. That's awkward, but you could say position is rising. Ooh, if you're a polar point, wait, that'd be weird. That would be like an r of theta. And if dr d theta was positive, then r would be increasing. But what would that mean if r is increasing? I know, I just threw you for the loop. I sent you into polar mode. Polar mode is the one with concentric circles, right? And you have thetas and you have r's. If r is increasing, what's happening to the point? Further from the pole. Further from the pole. It's not going right or left or up or down. It's going out away from the pole. Oh, stinky. Okay. So we have to think about what this quantity is as far as him increasing, what that means in context of the problem. But whatever the quantity is, it's increasing. So what's going on if the first derivative is negative? Okay, that's easy. Let's go to the second derivative. That gets fun. If the second derivative is positive, in context of the problem, talking about quantities changing, I do not want to hear concave up. So, in context of the original quantity, what does that mean?
Function is increasing.
Not increasing because we don't know, but you could say changing. Well, but I can have a concave, it'd be a min, but I can have concave up at non-mins. I don't know, it's a critical number. It's not approaching a curve, it's on a curve if there's concavity, right? Kevin, you were close.
The slope is approaching.
Don't say approaching. The slope of the derivative is positive, but no, that doesn't really help me with the word salad. What are you saying, Patricia?
The rate is increasing.
There you go. We could say the rate of f. Well, I didn't specifically say it. Is increasing, right? But couldn't you also say, in context of what Kevin was trying to say, which is sometimes nicer, he said what did you say, the quantity? Or did you say f? When you started to say increasing, I said, no, say changing.
I said f prime is increasing.
Oh, and then I said true, but in relationship to the original. The rate of f is increasing, or we could say f is changing at an increasing rate. The AP usually likes this wording better. So the bananas are being stocked at an increasing rate. The snow is falling at an increasing rate. The corn is being eaten by the mice at an increasing rate. I don't know. Corn in the silo, there are usually mice in the silo. The mice eat the corn. That was a problem at some point. Did you guys have mice in your corn problem?
We had a mouse inside my garden.
I was making that FRQ about that. Anyway.
Increasing one where they're just adding corn into the silo.
Oh, they were just adding corn. But see, it would have been great like the banana problem from 2 years ago where customers were taking the bananas off the display and then someone came in to work and started stocking, and so you had people taking out and then you had someone stocking in, but then some of it had been taken out before they started stocking. Anyway, that's why I brought up the the mouse. Because you could be adding corn into the silo and the mice could be eating this corn. Does that make sense? So going in and then coming out, being added to but then being subtracted. Anyway, oil being spilled into the ocean, there's a leak and it's going out, but then you have someone trying to pump it up. Is that happening like this? The amount of oil in the ocean, is it still increasing or is it finally decreasing? Climate change, what? Do you guys know there are actual things out there that can take carbon emissions out of the atmosphere?
How do you know?
It's not enough just to stop it. Why don't we just start not being on the defensive, but being on the offensive? Why does no one give them funding? Corrupt political, anyway, let's come back. But maybe we shouldn't just be thinking of adding the carbon emissions into the atmosphere, but also we could be subtracting them. That might be more effective. If we could put all the great minds together on a problem and actually like do what they say regardless of financial gain to any single person, who knows what could get done. Yes. There's a lot of political machines behind Greta, just be careful. There's personal gain behind Greta, just be careful. Anyway, coming back. Absolute prime of x is less than 0. What does that mean? Well, can't we just take all of this and then just go the opposite way? The rate of f is decreasing, or f is changing at not un, that's not grammatically correct. We only use an when we have a vowel in the next word, right? Decreasing rate. Question. Kevin, why did I stop you? Because you were starting to say this, and I made you change increasing to changing. Do you know why?
Because when I say increasing, it could be like increasing at a negative, I guess, rate. If it's like concave down, right? So like, if the function is increasing and it's concave down, the rate approaches like 0, so therefore it's decreasing.
I think you're saying it right, just your words are being a little jumbled, but you're saying it right. This, I mean, if we're thinking about the graph, that could be concave up, right?
Yeah.
For my original function f. And then this one is concave down for my original function f. Couldn't f be decreasing and still concave up?
Yeah.
Or increasing and concave up? But this entire time, it has an increasing rate. This entire time. So whether f is decreasing or increasing, its rate is still increasing this whole concave up time. So I can't say which one because I know nothing about the first derivative. I know nothing about the actual nature, decreasing, increasing nature of f. From this clue, I know nothing about this word. Maybe down, maybe up, I don't know. But increasing rate, yes. I just crossed it out. Concave down. Sometimes f is increasing in the concave down portion, sometimes decreasing. I know nothing about how f is changing. I just know what its rate is doing. Does that make sense? Yeah. Let's move on. No! What's this page? No, what's this page? And do you actually need to write it all? Come on, we're lazy, right? Let's think efficiently, effectively. What do we need from this page and what is it trying to give to you? That's not the point of the page. Okay, hold on. Whoa! Have I already talked about absolute extrema this section? Ryan, you were gone. You can't be saying yes or no. Have I talked about? Unless you did the video last night, then I apologize. I've got a condition on my apology. Come back. Have I talked about absolute extrema? Yes. We talked about the extreme value theorem, because the extreme value theorem says if a function is continuous on a closed interval, there must be a highest, a lowest, which was indicating an absolute max and an absolute min. But then I said, oh, stuff could go wrong. We talked about EBT and how absolute extrema. To find the absolute highest and absolute lowest, we need to look at critical numbers and endpoints. What is this? It's the whole page of what to think about with absolute extrema, but not just for continuous and closed interval functions, also for, what if we don't have endpoints? Or what if we have discontinuities? Here's the deal, we've already talked about it, so if that was enough, you don't really need to write this page. I'm going to get you to an example soon. But if what we talked about in a very short, sweet, summarized version is not enough, safer to write the page. So continuous function on a closed interval, this is EBT, this is, hey, you're looking for both and you're going to find both. This is, the highest is going to be the absolute max and the lowest is going to be the absolute min. And everything is going to be fine and dandy, frolicking in fields of daisies. I don't know. Because all you gotta do is just take all of your x's and your c's and put them into a table. Testing with your original quantity or whatever you want the absolute max of. And find the highest value and the lowest value. And we already talked about the of versus the at, right? The of is which one again? The highest value of or the maximum value of? Is it the y or the x? That's the y. If they want the minimum value, that's the y value. If they want the x value or the at or the when, that's the x. So look in our tables, testing in our original function. But the bottom part says, what if there are no endpoints? Or what if we have a partially open, technically we could also put, or if we have like an open at A but closed at B, or if we have it closed at A and open at B. If it's not totally closed, all guarantees are off, and we have to be super careful of things like domain, discontinuities, and endpoints. And here's the struggle. Somebody the other day was like, oh, hey, it's an open interval, so just ignore the endpoints. But we can't ignore the endpoints because what do we still have to consider? Consider the heights the function is at the endpoints, because if the endpoint is not included and yet it's the highest, therefore no max will exist of that function, or vice versa. If at the endpoint it's the lowest out of all of the candidates, and the function behavior doesn't have it going to like a vertical asymptote and decreasing without bound or something like that. If the endpoint is the lowest and not included, well, bummer, no min either. Discontinuities, I'll say specifically watch out for vertical asymptotes, because remember, vertical asymptotes, my function will either go to infinity or negative infinity, and either a max is totally out of the question or a min is totally out of the question. So basically, this whole page is just like keep your wits about you and figure out what the function's doing, and then make a educated and informed decision. There you go. An informed decision based on the highest, the lowest, if they exist, and where they exist. And so, along those lines, let me get you a fully worked out absolute extrema question. For those of you that are like, I know these steps, cool. Would you have done them here? Don't worry, I have a harder one coming. You're just seeing if this one makes sense. This one's all worked out. I'll bring my work down. This one's all worked out. This all makes sense. Would you have done it this way? I have a harder one coming, and that one I'll let you guys work through in your groups. Oof, there's a lot of writing, and it's tiny. We guys see the first function, right? First function, alright, got it. Find the extrema. The extrema. Doesn't say local, doesn't say relative, even though we'll probably do that in the process, so I assume absolute. On the closed interval. Alright, is the function continuous? Wait. He's a polynomial. What are all polynomials? Okay, so once again, is the function continuous? Yes. On the closed interval? Okay. Do you see me finding critical points? On the far right, I take a derivative, I factor, I find my critical points. Do you see me take my endpoints? Do you see me throw them all on the table? Why did I use all of them? 0 and 1 were both in my interval. Sometimes critical numbers are outside the interval, and that's an interval. I have to use all of them because they're all possible. I see a lowest. I see a highest. What does that mean? Well, my lowest is at a critical number, which means it will be a local min. I heard John say local. I only have one local min. Do you see the local min? My absolute min is my local min. It's at a critical number, so, and it's of a polynomial which only has smooth terms. So I know I have a horizontal tangent here. That's a relative min, and it's the lowest, so absolute min. Where's my absolute max? I'm talking about at 216, if I'm talking about the closed interval, I actually can call it a relative, because we kind of change our definition of relative on closed intervals like we do with continuous, and so technically it is the highest of the region around it from the legal direction, because we're not coming from the other direction. And I think our book might call him local. The AP though would just call him absolute because you don't have both sides. So I would just say at the endpoint, absolute max, and at the horizontal tangent line, or at the relative min, you have an absolute min. But guys, you have to be careful of the AP here, because sometimes they do enjoy taking points off. I shouldn't say enjoy. I don't think they enjoy doing it. But they have a reason, and they do it. They will take points off if your justification is not sufficient. Now here's the struggle. I have sat in a seminar last year actually, where the head AP, the guy who was over it all, which I think it's like the presidency, you can only be in there so many years until you have to like advocate and let someone else in. So I think this year actually he's either transitioning out this year or he is out and his predecessor is in. But either way, he was in charge. And he was explaining with no added directions of explain or justify why they would have taken off points if you hadn't shown the testing at the critical numbers and the endpoints. And if you hadn't put it in the words. Oh, seriously? He means that's because they have all this higher math particular knowledge that's like well, depending on the situation, this and this and this and this and this, so they have to make sure that you know what you're doing. Yes, this is the lowest value. Yes, this is the highest value. Yes, that means there is an absolute min at 1, an absolute max at 2, and the highest it goes is 16, and the lowest it goes is -1 on this interval. But put in there somewhere that you are and you have considered all the candidates. Yes, your table is theoretically sufficient, but some people don't always show the table and they just get the answers quick, and if they don't put it in the wording that they have tested the critical numbers and the endpoints, even though it doesn't say explain or justify, they will take off. I'm not saying you need both, I'm saying you need one, so to be safe I tell you to need both. So out of this entire page, what's the most dangerous part for you guys to possibly leave off? The candidates. The testing of the candidates. Yeah. Whether you show it in the table or whether you show it in that. Careful. For things like critical numbers and relative extrema, a sign chart is not enough. You have to use the words. Hence why I'm having you do it here. Yes, you show the math, but yes, also test the candidates. And why is this awkward? You ready to hear how nasty it was, the thing that he was explaining? Kids had not even worried about a relative min when looking for a max. And they took off. No, it's a relative min. Conceptually, that makes no sense. There's no way. He said he didn't test all the candidates. Like, no. I know. Teachers were getting mad in that meeting. But they said you have to test all the candidates. To see how weird it is. Some of you who are like, oh, well, I just automatically ignore that one, because of course it's that. They want to see that you tested all the candidates, all the critical numbers, and all the endpoints, which goes against a lot of what I've been teaching the last few years, specifically in this problem. So I'm like, if it's a relative min, forget it. It's not a max. Let's keep looking. So we're just testing everybody, and saying the highest or the lowest or both, whatever they're asking. You guys caught how nasty that was, right? They didn't test the min, looking for the max. Tell me about it. Anyway, let's keep going. Alright, your turn. Ready, set. It's a surprise. Go. And I didn't give you a closed interval. Go. You have to consider the big picture. The entire function. Find me the extreme. Awkward family tree stuff going on out there. Judah's my dad, and now we found Judah, so therefore. At least they're playing with logic. Tina's my dad. Judah. I'm guessing one of the friends is like, and then there's a girl with a crush on the island.
Oh no, they're sixth graders.
Exactly.
Oh god.
It's okay. I should just stop the recording, steal that, and send it to the sixth grade teacher. Just kidding. Let's not crush their students yet.
No, I forgot.
Okay, work in your groups. Find an extra. Talk it out. Talk it out. Talk it out.
Derive
All your voice cracks. Christina. Talk it out. It's not straightforward. Joe was Lorenzo. Poor Jacob just sitting there being like, well, it'd be nice if my group passed.
So,
Jacob's like, oh, hi guys.
wait, hold on.
I'm sorry. I'm sorry.
Wait, what? Okay, where are the endpoints?
Farmville, they try and vote it poison and next
What's
one,
the
they're
speed
gonna
up?
pass deliver to flavor.
No, it's just reality.
Oh,
Okay, so crits are
So
one
it's like
on one.
this.
For zero to quick crit.
Alright, so
Okay.
negative 4x is the derivative, and 1 is the derivative.
Okay, crit.
Kyrie, you have a whole group that would love to talk to you.
Do we know the
That
endpoints?
equals negative 4. So that means the minimum is negative.
I think they were trying to find the relative max.
The max derivative
But
is
they lost it because they said equals 4.
so you need to find a derivative of that.
There's no domain called
Wait, no, because you have to set the derivative equal to 0.
Okay, so I have to
Oh yeah, negative 4x. X is
Okay, they reach the same point. And then you plug in 1, the top is 30 and the bottom is 10. So that means.
No.
Oh.
Wait, what?
it doesn't equal 0. So
Think?
not necessarily, you can't make it equal 0. But we'll just get to that later. Alright? So, alright, negative 4x equals 0 at x equals 0. So that's the, what's it called, candidate for a min or a max. So you plug it back in, x equals 0. So that's either 5 or 2. So we see that at x equals 0, the function either equals 5 or 2.
Okay, I think the min, you can find the 1. Hey, the min is at x equals 1.
Okay.
Be aware of your vocabulary. Be aware of what you're saying.
I
You
speak
have
so
the
loud.
idea and yet say it wrong. You would write it wrong. They would take off points.
I mean, hey,
Careful. How are you saying it? What are
do you know how we found the absolute min? The reason why?
Well,
Because I think the absolute min is right. I mean, I graphed it, so. Okay, so this is 0.
So 0.
This is negative 1. Wait.
Dean and Gavin, you can play with it too. Sorry you don't have collaborators to talk with.
or, yeah, there's no end.
Yeah. But this is a line, so it's probably right. So there's no absolute
Line
min.
is 2x squared, so it's a concave down plus 5. So
There's a local max without that.
Okay, so we know. So one of the
yeah,
local mins
the
is
max is at 5. Is not There's
Okay,
a max at 0.
negative 1. Negative 1 squared is 1.
So we were right.
So it looks like this. So that means there's a local max here.
Alright,
And a local min here.
5
They don't
at
equal each other
Judging
at
me
max.
again. They equal each other at 1.
I don't know.
Oh, right.
I'm not explaining this shit now. Kind of hard. But
No.
I'll just write.
But they're not differentiable then. Right?
It's continuous.
It's continuous, but they're not differentiable.
You do what
Okay.
They're not
Like,
I did that.
burn the life
They're both don't match up. Not the suit point, right, David?
Oh, I'm not explaining.
Hey, who gave you the .5 leg?
You want some of that?
No.
hold that out to the full natural numbers. I think.
As it should say, this justification is clear. Hopefully that's helpful. She's on 2 pages. That's fine. I guess I didn't need to write any of that because I ended up writing it later. That would have saved time. But that's just talking about my relative extrema. What was I actually supposed to be talking about? Probably absolute, but I decided to do a full analysis. I was like, yeah, why not? Just because who knows what the AP question might ask, right? Why were my critical numbers at both 0 and 1?
Because it's a piecewise, so you have to do it at the indicated, whatever it's called.
Partially, but to be honest, just because there's a separator doesn't always mean it should be included as a critical number, right? Just because there's a separator doesn't mean, why was this one a critical number? When we derived the bottom, we got 1. And what was I talking about up here? Do you guys realize why I said it was a sharp point? What's the derivative at 1? I didn't put it. Why didn't I put it? I should have. No, I shouldn't have. Why did I not include at 1? F prime of 1 does not exist because the one-sided limits of my derivative do not agree. At a sharp point, I can have, remember, DNEs or horizontal tangents. I have to include both as critical numbers. At 1, my derivative does not exist because the slopes do not agree. There's a sharp point there. DNE, that's a critical number. And then 0, that's a critical number. Yes, x equals 0 as well. So not all separators are going to be critical numbers, only if the derivatives don't match up there. Anyway, I had to use both 0 and 1. I did a quick restating of what the sign chart told me in order to talk through the relative max and min. I was all snazzy and just kind of did it like, hey, f prime is 0 and changes from that, or f prime is DNE and changes from that at hat, respectively. They say, sweet, 0 goes with that and 1 goes with that. Dun, 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 dun. That's snazzy. It's a trick. It's an AP trick. Using the word respectively, just kind of talking it out and then saying where, and it's like that goes with and that goes with. Anyway, but then why do I have a table down here?
Show the extreme values.
Yeah, to show me testing the critical numbers, but wait a minute, I thought we were supposed to test critical numbers and endpoints. Well, wait a minute, I test critical numbers and endpoints. I don't have endpoints. So what does that mean? What's the function's behavior? Since f of x approaches negative infinity as x approaches negative infinity, and f of x approaches positive infinity as x approaches positive infinity. You see it going up forever? You see it going, well, coming from down forever? Doesn't that mean there are no absolute extrema? You guys agree? It doesn't matter. Anything, there is none. The function is increasing without bound and decreasing without bound. There's no extrema. Now, if they had given me a closed interval, okay, maybe I should give you a closed interval. It would have been more fun. Or like a half closed interval. I could have closed it somewhere here, and you could have had a min and not a max. Next year, I'll try to think of that. But for right now, nope. It goes up forever, down forever. And just a few of you, you're like, I didn't have to do any of this. Well, couldn't you technically have graphed this guy to know he is a downwards parabola? He's a downwards parabola that comes all the way in until 3. And then this guy is a line, and he picks up at 3. Oh, hey, look. No absolute max, no absolute min, and there's a relative there and there. Well, you could have done that too. But I was working it out as though it was a harder function where you couldn't have just graphed it and looked at it and said, according to the graph, it has a high and a low. They wouldn't give you one that you could graph super easy. But a couple interesting things. That 1 was a critical number and should be included was a little interesting. Your sign chart should have shown you that though. Like, huh, that's weird. There's a min there. I wonder why there's a And then if you don't have a closed interval, you can't plug in your endpoints. You have to think about the behavior of the graph, and that might lead you to a deduction or an answer as far as the absolute extrema. Should have made it half closed, half open. That's a bummer. Oh well. Questions on the process? What if there had been like an A to B? What if I had said from like -5 to 7? What would you have added down here? -5 and a 7, then you would have tested, and there would have been a highest and a lowest. There would have been, yeah, because this function was continuous. Matches up right there. All right, with that, section 5.1, we're done, 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 done. What? We still have 3. Oh, that's it? Only 3 minutes now. I was all ready to go. All right, that's okay. I want you just to do number 47. Back of your homework spirals. You have time for 1 multiple choice. That should take 1.2 minutes, and you guys have 3 minutes instead. Man, I have to make it big. How do I make it big? All right, I'll just have you do 1. Which of the following values is the absolute maximum of the function 4x minus x squared plus 6 on the interval 0 to 4? Come on, geniuses, work it out. You got it. collaborating on a multiple choice question. Oh my goodness, you cheaters.
I said the answer out loud before I started working.
Oh, I didn't even hear you.
Wait, you don't want to spend nothing in finding a max. Yeah, here, Kevin, look. I built a mirror here so they can't see. Okay. I knew that's how do I know that you didn't just agree with me?
Exactly.
That I didn't quantum math. I should have said C and then you would have been yeah, other words in like
Just kidding.
No.
alright, you seem to have a little selection. I think I got Richard and Gordon's.
Keep your answers to yourselves. I will unveil it right before the bell rings, but we still have a minute and 20 seconds. You better double, triple check. Maybe you know why I'm saying that, and maybe you don't. Look at my table back there. Once you have the work done yourself, you'll know exactly why every single multiple choice answer is there. If you did the work, when you look at my table, you'll see why every single multiple choice answer is there. So who's the right one? And was your original hypothesis the right one, or would you naturally have gone with the wrong one? The wrong one. Sorry, there are 4 wrong ones and 1 right one. Do you normally have this much time just to ponder your work on a single multiple choice question? Where would your brain have gone? Would it have been right, or would it have been wrong? Pause! Smart AP guys, would they have made a question where you just pick the highest one? No. There would have been a higher value, and there would have been a reason there was a higher value, is that all I have to say? How many of you guys thought it was B? Or maybe one of the others? But what in the wording says it has to be E? It didn't say the word value, though. But it indicated value, didn't it? It said what? Oh, well, sorry. I was reading over here. I was saying my Alright, but which of the values, I mean, you can have X values, right? But which of the values is the absolute max of the function? They wanted the function value that was the max, which is 10. Alright, cool, kids. You know, homework is due tomorrow. You can get out of here. Oh my goodness, 12 seconds early. Bye. I'll see you later. Get out to that lunch line.